Okay, so now we are going to talk about object lifecycle management. So what we can, and again, we're going to talk about some different features in cloud storage, right? So let's go and have a look at a bucket. And let's look at object lifecycle first. So let's say I have a rule that I want to delete any objects that are more than 1 year old for whatever reason, right? I can configure that as a lifecycle rule, right? So I can add a rule, and first I have to choose an action. So in my case, the action will be delete, right? Then I got to set a condition for delete, right? So in my case, I'm going to say, well, the age of the object is more than 365 days, right? So when I create that rule will, after about 24 hours or so, it'll come into effect. So basically, now that I've created the rule, every 24 hours or so, my bucket will be automatically reviewed for objects older than 365 days. And if any are found, they will be deleted, right? So that's how I can automate my object lifecycle processing with object lifecycle rules. Now, again, I'll delete the rule because I don't want to delete all my old objects. But you'll see that is a feature that I can deploy, right? Okay, so let's look at some other features. So we can also turn on object versioning, right? So imagine that I've got objects that represent, say, documents or contracts, right? And I need to keep not only the current version of the object, but any previous versions of the object, right? So that is what I can do if I turn on object versioning. So that way, it will keep previous versions of the object. So objects that have either been changed or deleted, right? So they are considered non-current versions, right? Now, there is a cost, of course, of this because, if I'm storing two versions of the object, I've got to pay for both. But if I need to recover to previous versions of the object, this can be a handy objective, right? Okay, and the final thing here is retention policy. So again, imagine I have a scenario where I'm copying my contracts into a storage bucket, and for compliance reasons, I need to keep all those customer contracts for 5 years, right? So what I can do is I can set a retention policy of 5 years on my storage bucket. So what that means is that if somebody tries to delete an object in my storage bucket that is more than 5 years old, they won't be able, sorry, that is less than 5 years old, they won't be able to do it, right? So retention policy prevents accidental deletions that could violate your compliance rules. Right? So again, these are just optional features that we can configure on our storage buckets, right, for different use cases. Okay, so no questions on that. Good. Okay, so I'll just let you read that. I think we've covered it pretty well. So again, don't confuse retention with lifecycle management. Remember, retention specifies a minimum time that you've got to retain an object, right? And again, generally it's just for compliance reasons. Okay, so we saw how we can create the lifecycle policy at the console as I showed you, or we can do it at the CLI level with the gsutil lifecycle set command. But again, here we have to create the configuration file with the rule. So it's a little bit more work, right? Okay, now the other thing we can do is we can specify our encryption options, right? So the first thing to understand is that data in Google Cloud at rest, so in a cloud storage bucket or in a persistent disk, in a database, whatever, is always encrypted. The only choice you get to make is who will manage the encryption key. By default, it will be Google, which requires no configuration from the customer. But there are circumstances in which the customer would like to manage their own encryption key, right? So if the customer wants to do that, basically they've got to create a key. They've got to create their key in the key management service, right? So if I want to use customer managed encryption, so let's just say I want to use customer managed encryption for one of my disks, right? So what I can do is if I go in and let's say I want to create a disk, and I want to manage the key myself as a customer. So let's just call it my disk. And you'll see that if I scroll down here, you'll see here's my different encryption options, right? But if I choose customer managed, again, you see they're prompting me to select the key, right? So basically I have to have this key already set up in KMS, right? Otherwise, I can't use customer managed encryption because it says, okay, where's your key? It has to be in KMS, right? Customer supplied, on the other hand, is where the key is managed outside of Google Cloud, right? So don't confuse customer managed with customer supplied. With customer managed, your key needs to be defined in the KMS, right? So if I go into my KMS service, you'll see that I need to create a key ring, and a key ring is made up of keys. So once I've done that, then I can use customer managed encryption. But again, as a customer, I can do things like set the key rotation period, I can expire the key, etc., right, with KMS, right? But customer supplied, my key is outside of Google Cloud, right? It's not being managed through Google Cloud, right? So I've got a choice of those three encryption options. Now, there is a kind of like a fourth possibility, which is before you copy any data into the cloud, you encrypt it client side, right? So basically you send the data to cloud storage already encrypted, but this is not really a Google option, right? Google Cloud option, because as soon as you send that encrypted data to Google Cloud, it will be encrypted again, which, that could be fine, but it's not really an encryption option, right? Okay, so let's just make a start on some of the storage systems now. Just let me see what we've got here. Okay, yeah, we've got a little bit of time. So now we're going to talk about some of the managed storage systems, right? So the first thing is we need to understand the distinction between a custom storage database option and a managed solution, right? So imagine I've got a requirement. I want to run MS SQL Server database in Google Cloud. So actually there's two ways I can do it, two options. One is as an unmanaged service, where I create it in Compute Engine. and manage the database server myself. But the second option is as a managed database, where I create it in Cloud SQL and Google manages the database server. Right, so let's just talk about the difference, right? So first of all, if I want the unmanaged option, so you see that I go into Compute Engine, and basically when I create an instance, I can choose, so when I choose my operating system down here, I can choose Windows and SQL Server, right? So basically, I can choose SQL Server on Windows. I can choose whatever version of SQL Server and Windows I want there. But the thing is, once I create that instance, I, as a customer, will be responsible for managing it, right? But the other thing I can do is I can create it as a managed service within Cloud SQL, right? So if we go into Cloud SQL and create an instance. So again, I can choose SQL Server here. But in this case, it will be, and again, I can define what instance I want and so on, you know, how much memory, how much CPU, how much disk and so on. But in this case, Google Cloud will be managing my database server, right? So there's, and again, there's pros and cons of each approach, but in the first instance, we need to understand the difference between a managed service and just creating it ourselves and managing it ourselves as a customer. Right? Okay, so our focus here is going to be on the different managed services. And the first one, we've already discussed cloud storage, file store. The next one, the first one we're going to discuss, which we started to discuss, is Cloud SQL. Now, Cloud SQL, of course, we use when we want to create relational databases. And relational databases, again, I assume you're familiar with them. They organize the data in tables, and basically when I need to combine data from multiple tables, I need to do a join between the tables. Right? And again, there's many relational databases. It's been a very successful technology, but for Cloud SQL, the three database engines that are supported under Cloud SQL are MySQL, Postgres, and SQL Server. Now, you might say, what if I want to run a different relational database, like, for example, Oracle? Well, you can run Oracle on Google Cloud, but you cannot run it under Cloud SQL because it's not a supported engine. Well, there's other ways of running Oracle in Google Cloud, but not under Cloud SQL, right? So when we're using Cloud SQL, basically we have to choose a database engine like you saw, choose a region, choose my configuration. So, you know, how much CPU, how much memory I want on my database server, how much storage I want, which of course will depend on how big my database is, and so forth. But once I've created the server itself will be managed by Google Cloud, right? So it's a managed service, right? And of course, as a customer, I still have to design my database schema and design my application and so on. But the actual management of the database server, like the application of security patching, you know, the hardware and network, the monitoring of it, this will all be managed by Google. So that's why we say it's a managed service, right? Whereas go back to the example I showed you before, when I create my own SQL Server instance on Compute Engine, I would have to do all these things in green myself as a customer. Well, not the hardware, obviously, but I would have to monitor it. I would have to extend the database if it got full and so on. But as a managed service in Cloud SQL, I do not. Okay, and of course we can run all sorts of applications on relational databases, right? And there's also one thing they're talking about there is I can have a high availability option where I deploy a database into multiple zones so that if one zone fails, it fails over to the other zone. Right? Okay, so again, don't worry too much about the use case. Now, generally speaking, with Cloud SQL, if you want to scale the database, you're mainly doing what's called vertical scaling. So you're increasing the CPU and the memory available to the database instance. You can create read replicas as well, but that is not true horizontal scaling because, again, you can't do updates on read replicas. But they are useful in that you can offload some of your processing to them, right? So mainly with Cloud SQL, we're in the world of vertical scaling, right? But the read replicas we can use to do things like create copies of the data that we can use for backups or for read processing and so on. But the thing to be aware of is that the read replicas are not totally up to date with the latest changes, right? So basically they are replicas, but they're a little bit behind the state of the primary instance. So they're not perfect for high availability. Right. For high availability, we want this configuration where we have two instances, one in one zone and one in another. Notice that the zones have to be in the same region. And here my database is on a regional persistent disk, right? So that way, both of the instances can see the same thing on the database. So if the primary instance fails, the standby instance kicks in and I can continue to access